So a typical example of relative motion is these boats crossing rivers, and river have some flow of water, and the boat is just wants to cross from one bank to the other with some speed relative to the water, etc. So just pause the video and just read the question. And also, if you want to see the previous video, which is talking about this, the procedure of the relative motion, the transformation equations from one coordinate system to other, just hit this link. Okay, so with this type of questions, so first we have to draw the two reference frames, okay? And it is obvious in the question that one reference frame is going to be the Earth reference frame, and the other reference frame is going to be the reference frame that goes with the flow of water on the river. And let's label this as R, just for short for the river. So let me tell you about these coordinate systems. That again, if you want to see the transformations between these two coordinate systems, just see our previous video. So the Earth coordinate system, which I label as capital E, is the steady one, the steady coordinate system. Well, being steady or not is a relative quantity, according to somebody who is flowing with the water on the river is going to be steady, but the some reference point which is on the bank will move backwards, etc. These are relative things anyway. So, but it's not a big thing over here. Just we just draw two reference frames. One is for the Earth, and other is for the reference for the river. And you might have difficulty on realizing of what this river reference frame is. That by I'm drawing what by this R reference frame or river reference frame is, if you drop some object on the water, for example, with this water flowing, if you drop some object, the object will move with the water, and that object will be just the origin of this river reference frame, okay? Because according to the water, that object that you drop on the water will flow with the water, and it is not going to move relative to water if it's not swimming or if it's not pulled or dragged in any way. If you just release it and release with the flow of the water, that object is just steady with respect to the flow of water, and that object represents the origin of this coordinate system, okay, the second coordinate system that I label as river. All right, so, and there is this boat, and the boat is the object, okay? So I'm just putting some dot over here. Let me put this over here, okay? And this is the boat. All right. The object, the Earth reference frame, and the river reference frame. And these are the origins for these individual reference frames, okay? And the other thing is that the river, this reference frame, this point is moving with respect to this one, okay? Because the water is flowing. The water is flowing with the 5 kilometers per hour due east, and I just drawn over here that the east shows this direction, west is the opposite, north is up, and south is just opposite of north, which is down, okay? But you can convert this north to capital J as the unit vector in the positive y direction. S is minus J, and E is plus I, and west is just minus I. So with that, the water that flows with the 5 kilometers per hour due east is just 5 meter per second. Well, this is the velocity of the reference frame R measured from reference frame of E. Okay, if you draw, let me draw, if you draw the position vector from the origin of Earth reference frame to the origin of river reference frame, and just label this as RE, the vector, what this 5 kilometers per hour given in the problem is nothing but dr RE divided by dt, which is just VRE, and it is just given as 5 meter per second I. We should do this all, relate the given values in the problem, to the picture of the problem. So this, you should draw the picture representing the, the situation in the problem. So this is what you do. Now, what we have just done now is just we have figured out what is going to be the motion of the reference frame R, the river reference frame, relative to Earth. And this is it, okay? And the other is that the boat is moving. It says the problem, the boat crossing a river moves with a speed of 10 kilometers per hour relative to the water. So the word water, you can replace relative to river, okay? That means, in fact, if you just draw this position vector measured from the reference frame of the river, any object that flows with the water, okay, we'll see the motion of the boat. And this, let's call this is the position vector for the boat relative to river. And if you take the derivative, time derivative of this position vector, you will get v speed or velocity vector of the boat relative to water, and it is given in the problem. It says that it is 10 kilometers per hour what is the direction? Crossing, okay. Alright. If the boat heads due north, that means the boat, okay, is moving in upward direction relative to river, okay. So this is 10 kilometers per hour, okay. It is not, by the way, 5 meters per second, but 5 kilometers per hour. This is 5 kilometers per hour, I. And 10 kilometers per hour, J, okay, because it says that the part A of the problem, the boat heads due north, okay, and the boat heads due north means it is direction relative to water, okay. So I mean, if there were no any flow of the river, if you had a still water, then the boat would go in upward direction even with respect to the earth. But the boat is head is going up, means that it is moving toward the upward direction, in the north direction, relative to the river, okay. So that part is crucial, and that part is you have to figure it out in the problem. All right, so our problem is that what is going to be velocity vector for this boat if it is heading up? What is going to be direction of motion relative to earth? So what we do is just we also measure the position of the boat at any time by drawing this position vector of the boat relative to earth. Remember in the previous video that I was talking about this relative motion, that I made this transformation equation RBE, the position of the object relative to the fixed coordinate system. In this case, the fixed coordinate system, the steady coordinate system is Earth coordinate system, or somebody on the who is on the bank of the river. And it is the sum of these two vectors, RBR plus RRE. And you know, this equation that relates the position of any object with respect to these two coordinate systems, two reference frames, it's called the Galilean. I hope I'm correct in this word. Galilean transformation. Okay. And this position relation also converts with the same subscripts, converts to velocity relation. Velocity of the boat with respect to Earth is equal to velocity of the boat with respect to river plus the velocity of the river with respect to Earth. Okay. So we know that the velocity of the river with respect to Earth is just 5 kilometers per hour multiplied by I, and the velocity of the boat with respect to river is 10 kilometers per hour J. So just put these numbers, 10J, okay, plus 5I, and the units are kilometers per hour, and this will be the velocity measured, velocity of the boat measured by somebody who is on the bank of the river, okay, who is on Earth. So that's it. I mean, this is the vector. This was the question. This is the vector format. And as you see, even for the boat he's heading north on the water, somebody on the bank of the river, somebody on the earth will see the boat has also its motion along this direction. Although its head is due north, it will move like this. Head is north, but it will be dragging like this. It will be dragging like this. All right, because it's the sum of this horizontal component and the vertical component. So somebody on Earth will see that the boat is moving. If it starts, let's say, from this point, it will be moving in somewhat this direction. This is V boat relative to Earth. And this vector has the horizontal component, which is 5. It will have the vertical component, which is 10. So from this, you can easily find out what this angle is. This angle is going to be just, arctangent. This component divided by this one, and this is just 10 divided by 5. It is going to be the angle. And if you're also curious about the speed of the boat relative to the Earth, it is going to be just, VBE is just 10 squared plus 5 squared in squared kilometers per hour is going to be the speed. Okay. So this is the answer for part A. And for part B, the question is if the boat travels with the same speed of, again, 10 kilometers per hour relative to the river, which was the case, and is to travel due north relative to Earth. Okay. This time, its velocity vector direction relative to Earth is given as north. Okay. It is not dragging. The boat is not dragged by the water like the head is due north, but it's moving like this. So somebody on the Earth will is seeing the boat really actually moving right, crossing perpendicular the bank of the river going in this direction, even relative to Earth. So what will be its heading be in that case? I mean, its velocity relative to water. Okay. So, I mean, if I just open up some space by erasing these parts over here, this time, again, we have these velocity vectors. Let me draw the velocity vectors for part A. For part A, this was V, let's say, boat R, and this was V river with respect to Earth, and so some of these two vectors were V, the velocity of the boat with respect to Earth. So this was the vectors, velocity vectors, and this is a 90 degrees angle, velocity vectors for the part A. And for part B, the question says, well, this time we just measure the velocity vector of the boat to be right in the upward direction. Well, this is saying by part A, if the boat travels with the same speed relative to the river and is to travel due north relative to Earth. So it gives over here the boat now, the direction of the motion of the boat is relative to Earth and it is due north. So this is going to be V boat relative to Earth, and it is just we don't know it's the magnitude. Let's say VB speed multiplied by the unit vector J. Okay. But we know that still the water flows with this 5 kilometers per hour due east, which is in the positive x direction, and this is still the velocity of the river with respect to Earth. Okay. So the question is, what is the velocity vector of the boat relative to the river reference frame? So obviously, if the boat is moving directly perpendicular with respect to Earth, and if this is the velocity of the water flowing in this direction, obviously the boat must be head must be due in somewhat in this direction relative to, let me draw this as a straight line. Okay, this is going to be the velocity vector of the boat relative to river. Okay, otherwise, I mean, some of these two vectors will not give you this perpendicular vector, and this angle is just perpendicular. Okay, so we know that boat velocity speed relative to river is going to be 10 kilometers per hour. Okay, so this magnitude of VBR is given because it's the 10 kilometers relative to the river. So that's what it's talking about, this magnitude of this velocity vector. And we know this is still 5 I, and this is the magnitude of that, the magnitude of VBR is 10. Okay, and the question was, all right, this angle. All right, okay, so I mean, since all these velocity vectors geometrically looks like this, we can find by these three vectors are just forming a right triangle, and we know what the magnitude of this side, we know what the magnitude of this side, so we can figure out what this angle is, because this is the question: what is going to be direction of the boat's head relative to river? That's the question. So I mean, if you find just the angle, that's done. So if this is 10, and if this side is, the hypotenuse is 10, and if this side is just 5, that means sine of theta is nothing but 5 divided by 10, right? Which is 1/2. I think if sine of some angle is just 0.5, it is going to be just 30 degrees, if I'm not wrong. Alright, so I mean, just you can take arc sinus of this 5 divided by 10, and it's going to be, in terms of degrees, it's 30 degrees. So that means the river head must be showing a direction which is somewhat this is north and this is west, 30 degrees west of the north, and this is north and this is west. This is 30 degrees west of the north, this direction. All right.